Why does it turn blue? Well, it's through light processing, reflection, deflection from light. And what will happen is that you get a consistent layer of titanium oxide on this wire, which produces this blue color. And for me, this is great because blue is my favorite color. So these are my favorite files. Um, various research papers have been done concerning comparing the Vortex Blue, nickel titanium, and M-wire. And they have found that the Vortex Blue showed a greater resistance to cyclic fatigue and greater flexibility when compared to M-wire instruments. And you can see here in this graph comparing steel, super-elastic stock nickel titanium, M-wire, and the newest blue wire, that in the characteristics of flexibility, torque strength, and cyclic fatigue reduction, that cyclic fatigue resistance, that the M-wire or the blue wire outperforms definitely the steels and the stock nickel titanium and even the M-wire. So again, take advantage of the engineering and the technological principles that we are presented with in our profession. If you can do the procedure with a safer wire, why aren't we using it? That's always been my point of view on this. So I always try to keep up on the safest, most dependable technology that we can use. And this is definitely a characteristic of this new blue wire, this new Vortex Blue instrument. Cyclic fatigue testing, the Vortex Blue versus profile Vortex and the twisted file. And once again, no matter what the taper or the tip size, the Vortex Blue is outperforming the other three files. So again, take advantage of those engineering principles and the technology we have. You can get anywhere from a 65 to up to a 300% increase in increase in safety versus the profile Vortex or the M-wire for cyclic fatigue, and a 37 to 180% versus the twisted file. So again, the technology is working for us. How about torque fatigue? Well, again, once again, Vortex Blue outperforms the others, and again, in various diameters and taper. And again, the Vortex Blue safer in regards to torque fatigue than its competition. This is a very nice study that was done at the St. Louis University. It's a manuscript in progress. And this was done on size number 25 instruments. It compared twisted files, endosequence, profiles, profile Vortex, and the Vortex Blue at different tapers of 04 and 06 tapers. And they tested various instruments in a very scientific, very reproducible custom apparatus. The files were rotated and then made to go around a certain curvature until fracture. And it was recorded as a cyclic fatigue. And you can see here that the Vortex Blue outperformed all the other files that were tested. Compared to the original profile, it's almost 100% better than the original profiles. And you can see for yourself, it outperformed the other competitive files. As far as the 06 taper, again, the Vortex Blue outperformed the Vortex profile Vortex files, and again, almost 100% increase in 06 tapered cyclic fatigue resistance versus the original profile instruments. So the conclusions of the study were very obvious, that the Vortex Blue outperformed the other files, even outperformed the Vortex with M-wire, whether it was the 04 tapered instruments or the 06 tapered. Interesting observation was that the 04 tapered instruments were more resistant to cyclic fatigue than the actual 06 tapered instruments, which is something that I like to take advantage in my variable taper sequence. I like to finish apically with 04 tapered instruments, and I just like the aesthetic quality of the instrumented canal, but also to me in my hands, it feels like it's a safer apical file.